Hello everyone. Today we will derive electric field due to dipole at an axial point. So first of all, we should know what is dipole. Dipole is a combination of two charges. One is plus q, one is minus q, separated by some distance. We usually call it 2a. So this setup is called dipole. Okay. What will be the electric field due to this dipole at some distance? Okay. There are 2 points that we define for dipole. Suppose there is one more dipole. Okay. And the distance between dipole, we always take 2a as a standard distance. Okay. So any point which is perpendicular on the vertical bisector, if any point is present here of the dipole, that is called equatorial point. Okay. If any point is present in the straight line of the dipole here, any point P, this point is called axial. Okay, this is clear. So plus and minus q charge separated by a distance 2a is called dipole. There are two possible points where we are interested for dipole. One is perpendicular bisector, any point P, and this point is called equatorial point. Any point in the line joining plus q and minus q is called axial point. In this video, we will calculate the electric field at the axial point. Okay. So here I have taken one point P, which is axial point, and I am interested to find electric field at this point. Suppose this point is at a distance of x from the center of dipole. Okay, the distances from the dipole are always taken from the center. Okay, so from the central point, the distance of this point is p. The distance from this point p is x. So what will be the electric field at point p due to charge a? This is the first charge. Okay, so electric field due to a single charge. We should know the formula is kq by the distance square, right? This is the formula of electric field. So this will be kq by what is the distance from point A to point P? Because we are taking the electric field from point A to P. So the distance from A to P is how much? This is x. From here to here is x. And from here to here distance is A. And this distance is x. So what is the total distance from A to P? Just look carefully. From here to here is x. And from here to here is A. What is the total distance between A and P? It is nothing but A plus x. So this distance square. So this is the first value of field at point P. And what will be the direction? See, this is a plus charge. So whenever there is a plus charge, the value of field, electric field, is always outward from the charges. This is the direction of electric field. We should know it. For any negative charge, the electric field directions are always inward. Okay. So whenever we are finding the electric field due to positive charges, they are outward. And due to negative charges, they are inward. So here we are finding due to plus q, correct, at this point. So what will be the direction? So direction will be outward, away from the charge, away from it. So let me call this point P. So can I say the direction is towards Pn, correct, outward? Now I will find electric field at point due to B. B is this, correct, due to this charge, which is minus, due to this charge. See carefully. Okay. So what will be the field? KQ by D square. So it will be KQ by D. D is the distance that we are supposed to take. Okay. So what is the distance from B to P? What is the distance? If you look carefully, so this total is X and half of it is how much? You look carefully, draw it on your paper. Half of it is A. From here to here is A. And this total from here to here is X. So how much will be this? BP. Think about it. Isn't it X minus A? Correct? So it is X minus A squared. And the direction of electric field will be, because this is a negative charge, at this point, the direction of electric field will be towards the charge, right? So this will be this direction. So I can call it the left side, or I can call it towards PB, correct? P to B, this side. And the direction of this is this side, right? So these two are the electric fields available on point P. EPA is due to A and EPB is due to charge B. So what will be the net electric field? What should we do to find net electric field? E net. Should we add these two or we should subtract? They both are in opposite directions. Electric field, always remember, is a vector quantity. Okay. So if they are in the same direction, we are supposed to add. If two vectors are in opposite directions, what we are supposed to do? We are supposed to subtract. Correct? So I will subtract. So EPB minus EPA. Correct? Why I am subtracting EPB minus EPA? Because I feel EPB is more than EPA. Can you tell me why this is higher? Because see, B charge is closer to P. B charge is closer to P. Correct? The effect of B will be higher at point P. Second reason is, if you notice the denominator, for this, you look at the denominator. If you look at the denominator, this denominator and this denominator, this has a smaller value. If denominator is smaller, then definitely the quantity will be bigger. So according to me, I feel, one second guys, I feel that this value is bigger and this value is smaller. That's why we are subtracting. Okay. So if we subtract, what it will become? KQ by X minus A square. KQ by X plus A square. Correct? So what is the, I can take, first let me take KQ common. Right? Let me take KQ common. So KQ is common. So it is X minus A square X plus A square. Correct. Now LCM will be nothing but product of these two. I can multiply these two. So this is X minus A square and X plus A square. Okay. Now this will be going here and this here. So X plus A square minus X minus A square. Okay. So far it's okay. Let's simplify it. So this is X square A square plus 2AX. Okay. Minus, this is X square A square minus 2AX. And this is divided by X minus A and X plus A whole square. Perfect. So far is okay. Okay. See, this is also square. This is also square. So I have combined these two to put square. Okay. Okay. What can we do now? Think about it. What I am thinking is, if I remove this bracket, what do you think will happen? This sign and this sign will change. Yes. है ना? See it carefully. This will become minus and this will become minus and this will become plus. Yes or no? So this and this is cancelling. X square minus x square. This and this is cancelling. Perfect. Okay. Now it will be k cube. What is this? 2ax plus 2ax. It will become 4ax by, what is x plus a, x minus a? We know from mathematics. What is x plus a and x minus a? It will be x square minus a square whole square. Perfect. Okay. Now, what can we do? For the definition of, always remember, for dipole, the distance between plus q and minus q, this distance, 2a, is usually very, very tiny compared to the distances where we are measuring E. Compared to these distances, the distance between two charges is very small. See, for the diagram, for derivation purpose, I have shown big, but it's hardly 1 mm or 2 mm. And the distances where we are measuring electric field, they are about 1 meter or 2 meter. So 2a is very tiny, x is very big. So we can almost ignore 2a or we can ignore a in front of x. Correct? If I say x plus a, can I write it is almost x only? Or if I say x minus a, it is almost x only. Correct? When we are adding a very tiny quantity in a big quantity, it becomes x only. Okay? But remember, if I say x into a, that we cannot say x. Why? Because in product, if you multiply a big quantity with a small quantity, then quantity changes. Then we cannot ignore small numbers. So only in addition or subtraction we can ignore. Okay? So what I'm trying to say here is k cube 4ax. Here I will ignore this a. Because I am saying this is a small. So square of a small quantity will be further smaller. If a is very tiny, so a square will be very tiny. So I am ignoring it. So it is x square of square. Perfect. Okay. Now this is x power 1. And what is this x square of a square? What is this called? This is nothing but x power 4 square of a square. Correct? Anything is cancelling. Do you think so? X power 1 and x power 4. So these two will cancel this and this. So it will be x cube. Correct? So I am getting k cube 4a by x cube. Okay? We will do a little bit of rearrangement or manipulation. You will see what we will do. Can I write k and this I can write 2 into 2a into q. Can I write it this way? Just a little bit rearrangement. 4a, I am writing 2 into 2a into q. Correct? And we know what is 2aq. For a dipole, plus q and minus q dipole, which is separated by 2a, to write down the product of 2a into q, the product of distance and q. What do we call it? This is called dipole moment. This is called dipole moment. It's a very important quantity and its symbol is usually P. Its symbol is P. So I will use it here. So K into 2. So here, this 2 I have written here 2. And what is this becoming? This term. See carefully. 2aq is nothing but P. P is a vector quantity by x cube. So this is the net electric field due to a dipole. Okay. And for your information, K is nothing but 1 upon 4 pi epsilon naught. This is how it was defined. Okay. And the value of K is 9 into 10 raised to power 9. So this is the value of K with the unit Newton meter square per Coulomb square. Okay. So from here we can say the electric field due to dipole at axial point. Axial point means axial point means axial point means the point which is here in the same axis which is here. This is the axial point. So at the axial point, the electric field is this. Okay. So from here, what is the conclusion? Conclusion is that electric field is inversely proportional to xq. It means as we go away from the dipole, the electric field decreases with x. As the x will increase, it will drop quickly. It will drop very fast at a very fast pace because he is inversely proportional to xg. Okay. So practice this derivation once again. See you next video. Bye everyone.